I'm Aman and today we are going to solve again LeetCode problem. This one is comes under the array as well as tree problem, and it's a very basic and easy problem, so you can easily understand based on my explanation. So here we go to read the first of all read the topic. Was the topic of the problem, like convert sorted array to binary search tree. So you have to first of all know about some knowledge about binary search tree. What is it exactly? So I tell you in my theory part. So first of all, let's understand the problem itself. After that, I'm going to tell you what is binary search tree, what is its condition, and how we can draw binary search tree in the sorted array in the sorted form, and that how we can convert the sorted array into the binary search tree. So yeah, here the question given is, given an integer array number where the elements are sorted in ascending order, and we have to convert it to a height balanced binary search tree. And another point is here, height balanced binary search tree. What does it mean? Like whatever the binary tree that we are going to draw, it should be in a balanced order. So there is some condition for that, like it not be more than one, difference will be not more than one. And how it will be, like I tell you. So you can see in this example, let's say the my theory part that I am explaining you very easy way. So let's understand this first of all. What's the problem exactly? So you have given and sorted array, like whatever the example there I took that one. So -10, -3, 0, 5, 9. This is the sorted array, and that sorted array we have to convert it into BST, like binary search tree, and that binary search tree should be height balanced. Like you have converted it into a height balance BST. Height balance means basically for every node the difference between height of the left and right subtrees will be less than or equals to 1. It not should be more than 1. Okay, and this is the rule to make the balance BST, binary search tree. After that we have to take this also, sort that array. BST naturally follows these properties of BST, like there is some condition that follow the BST binary search tree. Based on that we have to draw the binary search tree. In the binary search tree basically we have three components: left subtree, root node, and right subtree. Basically these are the three things that we have to maintain. So the left subtree or the left node of a root node means, first of all we have one root node that we have to selected in from our given array. It should be the parent. After that we have subchilds, like left subtree and right subtree based on the root. So the left subtree should be less than root node, and the right subtree should be greater than root node. So we have to take that element which is less than root node in the left side, and and another side the value is greater than root node will be keep it to the right side of the subtree. Okay, so middle element of the array should be root node, whatever I said to you, because it divided the array evenly. Means we have to select the root node first. For that basically we are finding the middle element of the array, that will be divide the array into two equal halves, and whatever the middle we have to keep it as root node. Okay, yeah. So how we can solve this? Here I have written some approach. step by step how we can solve. So I think you will be understand like what is basically BST binary search tree, what's the condition it's follow to maintain the balance height of the tree, and what are the conditions that BST follows, like properties of BST, the left subtree, right subtree, and the root node, what they are follow basically. Okay, so let's see the question. In the question, what's the example given here? Like suppose in example 1 there is an input -10, -3, 0, 5 and 9. These are the inputs. So first of all we are going to find the middle element. Okay. So yeah, middle element is like dividing this given array into two parts and find the middle first. Okay, so if we are dividing the middle element, you can see clearly 0 that is present in the middle at index 2. So keep it as the root node. After that we are taking the elements for the left subtree and right subtree evenly. That's balance the height of the tree. So keep -3 in the left side, 9 or 5 in the right side. Like in the both condition you can see it is in balance order, or it's follow the conditions, or it's follow the properties of BST. Like in the left side should be less than and in right side should be greater than the root node. Okay, so output should be like 0 or whatever the root node here, 0. After that left subtree and right subtree, -3 and 9. After that again what is here, like, sorry I was paused the video for the, sorry for the interruption. So where I am like taking that input and what are the output that we are predicting. So 0 as the root node, 3 in the left side, left subtree, 9 is the right subtree, and again we are writing based on the root node. Now the root is become -3 and 9, like parent node is like 3 and 9, and the last node we are called is as leaf node. Like after that there is no node. So the uh, in the last row what are the nodes are available, they call it as leaf node. So yeah, for the 3, the left side is -10, right side is nothing, so we are write it as null. Again for the 9 as a sub parent, for that we have in the left is 5 and for the right is null, but we got the all root element, so we uh, write it up to 5 only, no need to write null part. Okay, so here's the explanation like how we are writing this, like 0, -10 and 5 in the left side, and null in the left side, -3 null and 9 in the right side. That is also accepted, like whatever given in this example. Again if we see in this example, input as 1 and 3. Okay, so the output should be like anything. Like if we take it as 3 as the root, then 1 in the left side because it is less than root. If we take it as 1 as a root node, so 3 will be in right side. Okay, so yeah, the explanation is like that. If we take 1 as the root node, uh, sorry, 1 is the left node, then the root node is 3 and in the right side is null. So output like 3 and 1, or the height is in balance order, like 0 and 1, height is only 1 here. In this, if we see how we are calculating the height, so yeah, here is the 0 1. Okay, again 2. Before that here if we see the levels of the, based on the level we are finding the height of the tree. it is in balance order or not. So for 3 and 9, the height of the tree is 1. If we are taking 10, for the 3 is 1, for the 0 is from here to here is 0, 1 and 2. Height is here 2 for the 10. For the root node as 0, height is here, uh, height for up to 10 is 2, and in the left side if we are checking like 0, 1 and 2, uh, again here is 2 and 2, 2 left minus right is equals to 0. If we are subtracting both root height, both side height, it should be not more than 1. That's what I'm saying to you, and it's a property that we have to maintain. The height should not be more than 2. It will be up to 1 only. So yeah, here is this examples also. Let's see in my notes how we can solve this problem. So first of all, we have to choose the middle element as the root node. How we are selecting this? Like say in this example, like whatever we have example 10 minus 3 0 5 and 9, these are the array element that is in sorted order, so no need to sort that array of element. So here we can see in the genuine way 0 is the middle element, so it should be the root value. Recursively we are building the left and right subtree. How we are building, like whatever the element that are present to the 0 in left, it should be the leftmost element or the left subtree, and whatever the element which are present to the right side of 0, it is in right subtree. So yeah, that is 5 and 9 repeated. Repeat this process until we are getting not getting the child node or the leaf node. So repeat, keep dividing the array into two halves or halves. Okay, middle element become the root of subtree. Left will be the left child, right half will be the right child. Ensure that BST property maintain the tree remains, the height is balanced. We have to balance that tree whether it is followed or not. If not balanced, we have to just change the element in the correct order. Okay, so the next thing is the coding part, how we are going to implement this. Okay, so basically in the problem itself given all these things, let's say in the here only, like we have already initialized the left node, right node in this basic code structure. So directly I'm going into this. Okay, so here I'm using function property that is easy to solve this. Basically we are returning the element like number from 0 index to the length of the number minus 1. What are the arrays length? Minus 1 we are going to return from 0 to length minus 1, whatever the length of the array minus 1. Okay, so the how we are building this, like in my function build BST, how we are going to build, like take number, take left and right. Okay, if left is less than right, return simply null. Suppose we are taking the root element. If the element not existing any left node or right node, then we have to simply return the null because there is no element. That's why there is the left is less than right. It is possible when there is no element. So if there are no if there is no element, then it will return null. After that we are finding the middle element of the array. How we are going to find that? By applying this formula, or we can do simply one thing, left plus right divided by 2. I'm doing something like in the other way, like how I'm calculating this. In this you can see like middle equals to left plus right minus left divided by 2. How it's working, like I'm going to show you by the first example. Like suppose we have this element, okay, I'm going to tell you in the bottom. These are the elements, okay, 0, sorry, 0, 1, 2, 3 and 4. How it's working, like left plus right minus left divided by 2, okay. So what is our leftmost element? 0 plus rightmost element is 4. 4, okay, minus 0 divided by 2, okay. Then what it will give? 0 plus 4 minus 0, it gives 4 by 2, 4 by 2, and it will give the output as 2. So the second index element should be the middle element, okay. So here we can say 0, see here, 0 1 2, okay. 0, 0 is 10, 1 is 3, 0, second index add element is 0. So 0 is the root node here for this, okay. And after that we are traverse the node finding middle element until we reach the last node or the last index element, okay. If the in the left side, what we have to write, like number of build number left, whatever the element in the left side, okay, mid minus 1, like after the mid we have to sorry, before the mid we have whatever the element we have to keep inside, like smaller than the root node. And in the right side, same as in the right side, we have to take the element which is greater than mid, okay. After that, at the end we have to return root, and that function will be goes into this, and it will take one by one the array of elements, and it will give the output like one by one number. After that, the zero index to the length of the array of element minus 1, up to that it will print in that, okay. So output should be like this: 0 minus 3 9 minus 10 null and 5. You have some question regarding this, how we are going to get this null? Because of this, in the left of the minus 3 having minus 10 as a child node, but for the right side there is no element, or the right node is not there. That's why we are taking as null. After that we are going to backtrack and just backtracking, or we are going back and checking what are the elements in the right side that we have to print again. So up to minus 3 9, and now up to like 0 is the root node, minus 3 is the left subtree, 9 is the right subtree. Again after that 3 is the root node for the left side. So minus 3, what are the element is less than minus 3 we are going to take, like in the left side, and what are the element which are greater than the minus 3 we are taking as in right side. So minus 10 is available which is less than minus 3, so we are taking in the left minus 10, but in the right side there is no element, so we are taking as null whatever here written, minus 10 after that null, because right side is nothing. And remaining we have 5 is left to add in the tree, so we are going to the right side because 5 is greater than 0. So after that 9 we have already taken, the right subtree. So 9 is the root node. Based on that, we are assigning 5 to the left side because uh, left subtree, because of 9 is greater than 5 and the left subtree will be less than right, and the right subtree should be greater than root node. Okay, so based on the root, we have to assigning the each element here one by one. Okay, I think you understand, but if you have any confusion related to this problem, you can just ask me. I'll tell you in easy way. If possible, I'll make another note. If you are not understand, based on my notes, you can see. So thank you for watching my video, and I'm ensuring that in the next upcoming video I try to solve in best. I try my best and in the best form of video. Like I think there is some like issues related to in the understanding form, because I am just like giving a lecture type uh, conversation between me and you, like there is no practical things. That's why I think so. So if I get this as the issue, I'll try to resolve that one. So let's run this problem. It's passing the board test cache, and you can see here we have beats the 100%. So yeah, thank you everyone. Keep watching my videos.